Hi, and welcome to Allen High School's discussion of electrochemistry at the AP/IB/HL level. We're going to jump right into the fray. We've been talking about electrolysis. This is a picture of an electroplating setup, and I'm going to expect you to be able to fully label that. I'm not going to do it in a video because you're going to learn it in your virtual lab. So if you don't understand some of this, you'll want to make sure you ask me in class. Instead, I want to zero in on a particular type of electrolysis. Let's start with the easy one, sodium chloride. What happens when we run a current through melted sodium chloride? Well, sodium chloride is +1, chloride is -1, right? Now, the only thing that can happen is for sodium to be reduced to pure sodium metal. Now, a few of you are getting a little confused on this. I remember with an aluminum reaction, you were having trouble. Pure substances all by themselves have an oxidation state of 0. Nothing to give electrons to, nothing to gain electrons from, and so they have an oxidation number of 0. Now, that means that chlorine would be oxidized. So sodium is reduced, therefore it's our oxidizing agent. Chlorine is oxidized, therefore it's our reducing agent. I'm going to go ahead and write the half reactions for this, even though it's fairly simple to balance. This would be my half reaction for my sodium, and then the chloride is going to chlorine, so I need at least 2 of them, and that would therefore involve 2 electrons. And so I would have to multiply that half reaction by 2 so that we can balance our electrons. So I need a 2 there and a 2 there. Hopefully pretty straightforward. Let's look at what happens when all we do is take this same sodium chloride and dump it in water first. We're going to talk about an aqueous sodium chloride. Now, we already know that in theory, sodium could be reduced to make sodium metal. And we know from above that chloride, 2 of them, you've got to balance those elements. We've got to balance electrons, charge, and mass. Electrons, charge, and mass when we do these. So I'm going to make Cl2 plus 2 electrons. So we know that's a possible oxidation. Here's where a little bit of a twist comes into play. Not only do we have sodium chloride in the solution, we also have water in the solution. So we have a competing process happening. And so I'm going to write water's half reaction here. The reduction of water involves the reduction of the hydrogen in water. So I would make hydrogen gas plus 2 hydroxides. So this would form a basic solution. And hopefully you know you could test that with, say, phenolphthalein, and it would turn pink if we had phenolphthalein there. Now, our competing oxidation would be the oxidation of water. And I strongly recommend that you can either, by the end of this unit, know how to balance these 2 half reactions or memorize the half reactions for the oxidation and reduction of water. Now, 2 oxygens were oxidized, 2 electrons each, so that's a total of 4 electrons. Now, determining which one is reduced is pretty easy. I hope by now you know you're never, ever, ever going to form a pure or a metallic alkali metal in water. Alkali metals react very violently in water. You're not going to make pure sodium in water. So that's out. We don't even need to look at redox potentials to know that that's out. Now, what is a little more tricky are these 2. The redox potential for the chlorine is 1.36. You can look that up. You don't memorize those numbers. Volts. The standard reduction potential for oxygen is equal to 1.23 volts. So we would predict. Now, experiments may prove otherwise because these are so very close, but our prediction would be that oxygen would be oxidized. Remember, when we're looking for the spontaneous oxidation, we're looking for the most negative to be oxidized. So this is more negative or less positive, however you want to think of it. And so that's out, and that leaves us with basically reducing and oxidizing water, the electrolysis of water. So be very, very careful. It's kind of a tricky question. They're not trying to trick you by asking you this. They're trying to probe for a deeper understanding for you to think about the chemistry of the solution. And you guys are so amazing. I know you'll be able to do it, and you'll make me proud. So until then, this is signing off.